question. No. So we have a similar question. Is this one? This one is similar. It's similar. So we will run very quickly. This one. You find the pump power. This one is question 4 into tutorial 6. And ideal flow. Ideal flow. Ideal flow. Okay. We have water here. And pump this way. And for example, I call this one is point A. This one is point B. This one is point I. This one is point E exists. This one is point C. This one is point D. Okay. Pump power. How to find pump power? Similar to previous question. It's very similar. To find pump power, it means you have to find S pump. You have to find S pump. Okay. S pump. To find S pump, energy equation. And to write energy equation, choose 2 points. Which point you choose in this case? A, B, I, E, C, or D? Which points you choose? Which point you choose? A and I. A and I, between A and I, we don't have the pump. We don't have pump between A and I. So when we write energy equation between A and I, we don't have S pump. So not A and I. Okay. To write pump power, we have to choose 2 points, and the pump is between 2 points. So in this case, maybe it's A and D, not A and I. Okay, because I, in this case, we don't have cavitation, not cavitation. So PI, we don't know. PI, we don't know PI. Okay, so A and D. Maybe it's A and D. Because A, we have pressure, we have PA, we have VA, and ZA. For example, Z0 here. So A, we have everything. Okay, and D, we have ZD. Okay, and we have PD. VB, we don't know. We know 2 things. Point E, we only know ZE, no pressure, no velocity. I, ZI, no pressure, no velocity. No pressure, because in this case, we don't have cavitation. No cavitation is mean PI higher than vapor pressure. Higher, but we don't know. Okay. B, ZB. And anything and anything about point B, you know, when we have this one. Do you think we can find one more protein at point B? Point B. Point B is this point. Okay, or in this section. We have full flow in this way, not flow in this this one, not flow in this one, flow this way. So in this way, you have PB For example, here you have this one is M, N, PB, N below B. So PB will be equal to PN minus rho. Rho is here is rho of water, Z, and 0.6. This one is fluid static. Okay, PB equal to PN minus rho Z, H rho Z, or 0.6, which is rho of water. Okay, and pressure at N you can find from pressure at M. This one is fluid static. In this system, is fluid static. Okay, this PM will be equal to PN. Sorry, PN. You write PN. PN will be equal to PM minus rho of mercury gravity times the distance from M to N is 0.175. Okay, and PM, this one is open area, so PM equal to atmospheric pressure or 101,300 Pascal. Okay, it means based on fluid static you can find PB. PB you can find. Okay, because PM equal to atmospheric pressure and PN equal to PM minus rho mercury Z and 0.175. PM higher than PN because M below N. Okay, and PN is higher than PB. PB will be equal to PN minus rho water gravity times 0.6. Okay, so from this one you can find PB. It means PB, you know, two things is ZB and pressure. Okay, but we have to write the energy equation to find S pump. We have to write energy equation between 2 points, and we have pump between 2 points. So we have choose A and D. Okay, A and D. So energy equation between A and D. We will have PA rho Z VA square 2Z. That's A. Between A and D, we have pump, S pump. Okay, equal to point D, PD over rho Z, VD square over 2Z. That's D. Okay. With PA, it's atmospheric pressure 101,300 Pascal. Atmospheric pressure. Okay. VA is 0 because A is water surface. That's A 0. Okay. PD atmospheric pressure 101,300 Pascal. So in this case, we can cancel out pressure energy. Same. Yeah. ZD is 2.4 plus 0.9. 2.4 plus 0.9 meter. Okay. It means to find S pump, you have to know VD, velocity. Velocity, VD. How to find VD? You have to find VD. How to find velocity? How to find velocity, VD? Yes, forward. Need to find flow rate is correct. Q. How to find Q? How to find Q? To find Q, you have to know velocity. But velocity is at a different point in the fluid flow. Okay, it means if you know the velocity at one point in the fluid flow, you can find the velocity at other points. Okay. So how to find velocity? And this one V is at which point? You think you can find velocity at which points? Yep, point B. You correct. So good. Point B. Because at point B, we know ZB and PB. We know two things. Okay. So maybe we can find V based on energy equation between point A and point B. Point A and B. Because now between A and B, we don't have uh, pump. Okay, so in the energy equation, you don't have S pump. We don't have pressure, velocity, and Z at point A and point B. Okay, but point A, we know everything. Point B, we know ZB and PB. So maybe based on the energy equation between A and B, we can find velocity. Okay, so A and B, we write the energy equation between point A and point B. Okay, so PA over rho Z, VA squared over 2Z, ZA equal to PB rho Z, VB squared over 2Z, ZB. Okay, ideal flow. And between A and B, we don't have pump, no turbine. So PB 101300, VA 0, ZA 0. Okay, ZB 2.4 meter. PB you can find from this one, PB from atmospheric pressure. Okay, from the atmospheric pressure. Okay, so PB you can find from here, this one. So you will have PB is let me see, is 101300 minus 229,200 Pascal. This one is PB. Okay, PB. So from this one, you can find VB. Because everything we have pressure PA, VA, ZA, we have PB, ZB, we have, so VB we can find from energy equation. Okay, VB will be 3.37 meters per second. Okay, so when we have VB, we can find flow rate. Flow rate. Q will be equal to VB times AB. Okay, VB, yeah, this one, and AB is pi. The diameter is 200 millimeter. Is 0.2 square over 4. So we have flow rate. Okay, and when we have flow rate, you can find VD equal to Q divided by AD. Okay, this AD is small pi, 75 millimeter. So AD will be equal to pi times 0.075 square over 4. Okay, so you have VD. When we have VD, I call this one equation 1. Okay. And VD in here we have here is 23.97 meters per second. Okay, so when we have VD from equation 1, we can find S pump. With S pump is 32.6 meter. Okay, and from S pump we can find P pump to S pump rho VQ. Okay, and this one is 33.9 kilowatt. Okay, this question is similar, very similar to the question, the question 1. But the difference in this question with question 1 is, in this question we don't have flow rate, and we have to find flow rate. Okay, in question 1 we have flow rate is we have air flow rate is 120 feet per second. It's mentioned in the question already. But in this question now we don't have flow rate. Okay, so to find the flow rate we have to know velocity. Okay, to find velocity you can base on energy equation. Okay, do you have any question?